Hi friends, welcome to all. In today's video, we will explore OSPF Single Area configuration using 3 Cisco routers. So we will learn how to establish connectivity, then verify neighbor relationship, and understand how OSPF dynamically shares routing information. So stay tuned till the end. Let's get started with the practical setup in Packet Tracer. Friends, I kindly request you to subscribe to our channel, and if you find these videos helpful, please like and share. Okay, we will design our topology. 3 routers, 2 switches, then PCs. Consider R1, R2, R3, S1, S2, PC1, PC2. We will connect all these devices. PC1, S1 FA0/1, then G0/1 to G0/0/1, G000 to R3 G000, then from R3 G001 to R2 G001, then G000 to S2, then to our PC2. Here between R1 and R2 we are going to connect using serial cable. So we need to add that module here. So let me put off this router, then add this module. So this is our serial module. Then put on this router. Coming to R2, put off and add this serial interface, serial module, and put on. Now we will connect serial from R1 serial 0/2/0 to serial 0/2/0. Okay, I just rearranged our topology. I labeled all the ports, and also here we can see we are going to use this network address here. For this R1 LAN, we are going to use 192.168.11.0. Then for this R2 LAN, we will use 192.168.22.0. And here between R1 and R2, we will use 172.16.20.0/30. Then between R1 and R3, 20.4. Then between R2 and R3, 20.8. All the interface IP address we given in our addressing table. So we will configure all these devices based on our addressing table. So first of all, here we are going to configure this R1 LAN. Just I will set the host name. Now we will go to interface G0/0/1. We will set the IP address. So as per our addressing table, 192.168.11.1. Then submit to mask. Then activate this interface. Here we can see the interface G0/0/1 is up. Now we will configure this PC1 IPv4 address 192.168.11.2. Then submit to mask. Default gateway 192.168.11.1. Next we will configure the R2 LAN. Interface is G0/0/0, which is connected to S2. We'll go to that interface G0/0/0, then set the IP address as per addressing table 192.168.22.1, then submit to mask. We will activate this interface. Then we will assign IP address to this PC2 192.168.22.2, then default gateway. Next, we will configure this point-to-point connection. First of all, from R1 to R2. Here we connected using a serial cable. We are going to configure this serial 0/2/0 on R1 and R2. And here we can see the network address we marked 172.16.20.0/30. So here we get two usable IP addresses. We'll go to R1. We'll go to interface serial 0/2/0 and set the IP address 172.16.20.1, then submit to mask. Activate this interface. Then coming to R2, interface serial 0/2/0, and we will set the IP address 172.16.20.2, then submit to mask. Activate this interface. Here we can see the link between R1 and R2 is up. Then we will configure the link between R1 and R3. Interface G0/0/0. Interface G0/0/0. IP address 172.16.20.5. Submit to mask. Then activate this interface. Then on the other side, on R3, interface G0/0/0, we'll give the next usable IP address. We will go to interface G0/0/0 and set the IP address 172.16.20.6. Then submit to mask. Activate this interface. We can see the link between R1 and R3 also up. And here between R2 and R3, 172.16.20.8. Interface G0/0/1, and we will set the IP address 172.16.20.9. Activate this interface. Then we will go to on R2. Interface G0/0/1, IP address 172.16.20.10. Then submit to mask. Activate this interface. Perfect. We can test the connectivity using ping, but just here I am going to use this add symbol PDU from PC1 to R1. Successful. Then from PC2 to R2, also from R1 to R2, then from R1 to R3, then from R2 to R3. Okay. So we just configured some basic settings, and also we configured IP address on all the devices. Now we are going to configure OSPF. So here we are going to configure OSPF with the single area, and we know that this single area OSPF is so simple. So first of all, we will configure it on R1. We'll give router OSPF, then we need to give a process ID. Okay, we'll give 1. Then we'll set the router ID 1.1.1.1. Then we will set the networks. So better we will give a command, show command, do show IP root connected, so that we can see all the connected network in this particular router. So here we can see those 3 connected networks: 172.16.20.0, 20.4, and our R1 LAN, that is 11.0. So we are going to configure this network now. So using this show command, very easily we can configure this directly connected networks. Network 172.16.20.0, then /30, we need to give the wildcard mask 0.0.0.3, area 0. Then network 20.4, so 172.16.20.4, wildcard mask 0.0.0.3, area 0. The network, our LAN network, that is 192.168.11.0 with wildcard mask and area 0. And also we are going to set the passive interface here, that the interface which is connected to switch. So that interface no need to send the OSPF packet to the switch. So we'll give passive interface G0/0/1. Now we will configure on R2 router OSPF 1, router ID 2.2.2.2. Then we will give do show IP root connected, so that we can see all the connected network here. Now we will give network 1 by 1, 172.16.20.0, then wildcard mask area 0. Then next network is at 20.8, then our LAN network 192.168.22.0, wildcard mask area 0. Here also we will set the passive interface which is connected to our switch, that is G0/0/0. Then finally we are going to configure R3 router OSPF 1, router ID 3.3.3.3, do show IP root connected. So here we can see 2 connected network. So we are going to set up the network 172.16.20.4 with wildcard mask area 0, then 20.8. So there is no passive interface. Perfect. We enabled OSPF on all the routers. Now we can test the connectivity. We will ping from PC1 to PC2. So from PC1 we will ping to 192.168.22.2, and here we can see we get the replies. Now we will verify the routing table here on all the routers. Show IP route. So here we can see our routing table. We can see all the connected network, and here we can see the network which learned with the help of OSPF. So 172.16.20.8/30, it's via the next hop address or the exit interface G0/0/0. So we can see here this interface, it goes through this route. Okay. And also we can see the network, remote network 192.168.22.0, which is our R2 LAN, and next hop address at 20.6, and exit interface is G0/0/0. That means the route is through R1, R3, R2, then PC2. It is not going through R1, R2 directly, because here the cost is 64. We are using serial cable here, and the bandwidth is less here compared to this. So we will verify that also. The same way we will go to R2. Show IP route, and here we can see those remote networks, that is 172.16.20.4, and also here we can see 192.168.11.0. So here if we observe this entry here, and we can see this administrative distance and the metrics given here. So the OSPF administrative distance is 110, and here we can see the metrics given, that is 2. So this is actually the metrics is cost here. So to reach to 172.16.20.4, so here is a 20.4, and it's a 2. We can see here a gigabit, so its cost is 1, and the other cost is 1, so total it is 2. The same way we can see here it's a 3 here, 192.168.11.0. So given the matrix 3, AD is 110 and matrix is 3. So it is going through R3, then R1, then it is going to PC1. So the value, I mean the cost is 3 here. It is not going through R2, R1, because here for this serial, the cost is 64. Just we will go to R3 also, and we will see the routing table. Show IP route, and here we can see R1 LAN and R2 LAN. Okay. So if you go to R1 and we'll give a show IP OSPF interface serial 0/2/0, so that we can see its cost here. Cost is 64. Show IP interface serial 0/2/0, and here we can see its IP address configured. So let me try with show interface serial 0/2/0, so that we can see its bandwidth here 1.544 megabit. Okay, or it is 1544 kbit. Fine. So the cost is 64. Here the best path from PC1 to PC2 is through R1, R3, R2, then to PC2, because here we have less cost between R1 and R3, that is 1, then between R3 and R2 again 1. So we will see that in simulation mode. So we'll enable only ICMP, and we are going to send a message from PC1 to PC2. So we can see it goes through S1, R1, then R3. So this is the best path. then R2, S2, then PC2. In the same way, back to PC1, same path, R2, R3, R1, S1 and PC1. So friends, that's all for today's session on OSPF single area configuration using 3 Cisco routers. I hope this video helped you understand how OSPF works in a single area setup. If you found it useful, don't forget to like, share and subscribe to our channel for more practical networking videos. Thanks for watching. See you in the next one.